All right, this week we're going to talk about flow control. There's a couple of things in terms of what we're going to need for flow control. You'll have homework assignment 2, which you'll see here. There will be a video that's posted down here. You guys can use this. Don't copy that specific example that's there. It's intended to give you a way to get through this. Be creative, create your own, that kind of stuff. You'll have the old videos out here, but I will have the video from this month as well. So I'm going to go ahead and make this current one unavailable, but we'll come back and fix that. All right. So what is flow control? Flow control is going to allow us to start working through our program pragmatically and thinking about how we're going to go from one statement to the next. And those are all done using flow control statements. So for example, if we look at this flow chart, we have where we start, we check to see if it's raining. If it's raining, yes. Do we have an umbrella? No. Then we wait a while. We go back to, is it raining? If it's raining, no, then we can go outside. We can see on this side, if it was a no statement to the beginning, we can go to outside. If we have an umbrella, yes, we can go outside and move our way down. So this is a standard program flow chart. Seems very simple, but it's very nice to put these into perspective when you're building larger programs. If you write these out ahead of time and then code against it, it's much easier to see where the program flows, at least at a high level. I wouldn't say do every single flow control flow chart. You're going to have a massive flow chart. Just at least the big portions of the program, have this out, then compartmentalize a flow chart that's just for that particular section if you need it. All right. So with flow charts, there's a couple of things we're going to talk about there. If you go out to diagrams.net, which is a link that's right there off of the Blackboard shell, you can create your own flow charts. And so you can come out here, create your own flow charts and do that. I used to have a homework assignment that required you to do that. I don't have that anymore. Just know that this tool is available for you. It's free. You can build your own flow charts to make sure you understand where your program's going. This is helpful for your midterm project and for your final project. Again, even if you just use it for the overall project, particularly if you guys are doing text adventure games and you start to get lost whether or not they went left, right, up, down, you might need that. Yeah. On diagrams.net. It's probably because it was trying to log in using your Google account. Try it in a private browser, see if it pops up. That's my guess in that. Okay. So for flow control, we're going to talk about Boolean values. In Python, there's 2 Boolean values, and this is a Boolean data type. Remember our data types from last week? We had integers, floats, and what? Integers, floats, strings, right? So this is our next data type, which is Boolean, and there's only 2 values that can be. It is either true or false. Note that Boolean values have to be capitalized T and a capitalized F for true and false. Big difference if you don't have that. Okay. For those, we will get a operator. So our goal here is that we're going to have a statement, right? A conditional statement. And we're going to evaluate that down to a Boolean value of either true or false. In this case, if you go back to the flow chart, it's yes or no, right? So comparison operators that we use, they're also known as relational operators. We will use a double equal to, or a double equal sign will be equal to. We will use an exclamation point equal sign is not equal to, less than, greater than, less than or equal to, greater than or equal to, right? So we can use these for numbers. We can use those for string value comparisons, etc. Obviously, less than, greater than, less than or equal to, or greater than or equal to is based on integer comparisons, right? Can't really use that with a string. Is A bigger than C? We can't do that. Now, there's ways that we can go about that to figure out if C is bigger than B, which there is a way to check that. But in most strings, you can't just check whether or not a is bigger than a B or is bigger than a C. So, but we can see if it is not equal to something or if it is equal to something inside of here. All right. Remember that a double equal sign is where we are checking to see if it's equal to. A single equal sign is showing this as an assignment operator. This is where people tend to get confused in the homework assignments. So for example, if I launch up the machine here, All right, we pull up idle. And we take a look at some of these comparison operators. So say we have name equals Jason, right? And we can have dog equals Beebs. Then we can see if name equals Jason, then we will print that is true. Or we can have an else statement here that will say something like print your dog's name is not Beebs. Okay. All right, we run this simple little program. And let's see here, documents. I think I created a folder on this yet. Okay. All right, so we run this and we can see that's true. And that's because we're using these conditional statements. So in this case, we're going to talk about if else here in a little bit. But right now, all we're checking is name equal to Jason? And because we specified name up here is equal to Jason, it works. If you have a single equal sign, the program in this code will tend to still run. In this case, it's going to give an error in this, but a lot of times that code may run inside of here. That's because you are actually assigning name to Jason, right? So if I didn't have this up here, it would go ahead and assign it. You need to make sure that you have two equal signs in order to do a check against it. All right. When we talk about Boolean operators, these are going to be things like and, or, and not. So what this allows us to do is to check to see if my name is Jason and the dog's name is Beebs, then we can go ahead and have a true value. Or we could say if the name is Jason or the dog's name is Beebs or not Beebs kind of thing. We can check it in there. All right. These Boolean operators evaluate down to what's called truth tables. So if it's true and it's true, it's true. If it's true and it's false, it's false. False and true is false. False and false is false. It's pretty common, right? I think you guys can pick up on those pretty easily. On the or operator, it's the opposite of everything, right? So if it's true or true, it's true. If it's true or false, it's true. False or true, it's true. And false is always false. And not is just the opposite of it. All right. You can mix these around so we can check to see if something is greater than 5, right? And that 5 is greater than 6. This would have to be true. This would have to be true. And that allows us to have true here. All right. Now we're going to get into conditional statements, and this gets into blocks of code. So some of you were talking about blocks of code last week where you had indentation and indentation spacing errors, that kind of thing. That is all important inside of Python, and we refer to those as blocks of code. So when we execute code in a program, we'll pull this back up here, you'll notice that everything is left aligned so far on the left-hand side until we get to our if statement. When we start doing if statements, while statements, anything like that, when it ends in a colon, you're going to indent the line below it in order to go to this as a block of code, which means this down here is a block of code. So start of true block, right? And this would be the start of the else block. And that's indented over. That runs until you have no more code over here, and then in which case it will go down to the next line and run the else code. If I start this as true, if it does not match this, it's going to run my else statement. If it does not match the, or if it does match this, it runs this code, but it never executes this code, right? It only runs the code in the block inside of here. All right. So there's a couple of those flow controls that we're going to work with. First one being if else statements. In an if statement, you have a if condition, right? We have the if keyword, just like we saw in here. We have a condition, AKA what is this? In this case, it's checking to see if that's true. If it's true, it's going to run this code. We can use else if we wanted to do something if it doesn't match it, right? We can also have elif statements. So we could say elif dog is equal to Beebs. Then we could do some code here. For example, print something like that. In which case, these are going to go through each order. So if this condition does not match, in other words, this is not true, then it's going to go down to the next condition of this elif and check to see if dogs is equal to this. If that's true, then this code executes. If it doesn't, it goes down to an else. You are not required to have elifs, and you're not required to have an else statement. So if I don't have these two, then either Jason is equal to name, or we just ignore this code in here and it never gets executed, right? So what's required in an elif statement is that you have something. Let's see here, didn't copy that all out. That's fine though. Go there, there. And now it's broke. Oh well. There it goes. All right. So again, this is just doing a simple flow chart. We're checking to see if the name is equal to Alice. If it's true, go ahead and print hi Alice. Then it goes down to the end. If it's false, it just goes to the end of the program. Else statements, you'll notice that my else statements just have the word else. There is no condition for those. So you're not checking to see if there's anything here. You're just simply saying else and then printing whatever code you want. All right. Elifs, you can have as many elifs as you want. The reason you would want elifs is if you want to make sure that you're catching certain conditions, right? So there's no difference between me doing if name equals Jason and doing if dog is Beebs. But if I want to catch all of these in here, then I will need an elif so that it goes down this chain, in which case it tests this one first, then it tests this one. If neither of those reacts, then the else statement gets printed. If I don't do an if and I don't do an else, then if these don't actually come true and true, then nothing gets printed at all. All right. A lot of times if you're wanting to check for different things. So for example, we could have something like name equals input so that we can get input from the user. Say something like, what is your name? Like that. And then we can check to see, is that name that? Elif name equal to Beebs. And then you can say that's my dog's name, or my name is Jason too. So now if we run this simple code or on an else, print, sorry, I don't know who you are. Very simple, right? Run this code. Make sure I got the right thing. Whoops, forgot that one there. All right, so now it's asking what my name is. If I say my name is Ab, then notice it doesn't know who I am. If I go through here and run this code again and say Jason, it will say my name is Jason too because it matched this first condition. If I go through here and do Beebs, it went through this first one. It did not match this condition. This ended up being false. So it skips this block of code, goes and tests this condition, in which case it matched and prints that code out. Yeah.
So syntax, using single quotes versus double quotes.
Yes.
Does Python recognize the difference between those two?
Doesn't. Not when it comes to strings. The only reason you want to pay attention here is notice the concatenation of the word dogs. It's better to always use double quotes so that if you ever have a contraction here, I say concatenation, if you have a contraction here, you never have that issue. Yep. You can also escape that character, which we'll talk about escape characters later. For now, the easiest way is to always use double quotes. Like I said, in my code, I'm horrible about that. I'll use one place and one another. It doesn't really affect it. All right. So we have ifs, elif, and else's. This is kind of nice where you can see this nice long chain. Again, this is making sure that we get a particular case. You could set up individual elif or individual if statements if you wanted to. So we could say where age is this. We're testing for multiple things. All right. We also have while loops. So while loops are going to keep us in a condition until it equals true. So a lot of times we'll use these in our code for while true loops. So if we say while true, then we will say print 5, for example, right? Now, as long as this condition is true, in which case we have the word true here, it's going to go indefinitely. And if you run this code, you're going to get code. What is your name? It's Jason. And now it's going to print 5 until I get this program to stop. Because we are in a while loop, it's just going to keep running print over and over and over and over and over. If you do this and you forgot to get some kind of way to get out of it, it's Control-C will end up breaking you out of a while loop. Okay? So Control-C on your keyboard, Ctrl-C will get you broken out of that loop. What we need over here is some way to break out of this while loop when we go through there. So we could say something like name equals input here. We'll actually just move this into a while true. There we go. And move this code inside of a while true statement now. And so now this code's going to run indefinitely until, if I get all my tabbing correct here. All right. Notice how this block of code is indented in here. So when you do a while true, you need to have the code inside. You can also have codes that are indented in. In other words, we have an if statement, and then we are going to need to make sure that this code is also indented in there as well. So indentation is important when you're dealing with Python. Okay. So this is going to go through, and if we have the name Jason, then we're going to put a break, meaning that if our name equals Jason, we're going to print my name is Jason. We're going to hit break, which breaks us out of this while loop. All right. If our name is Beebs, we're going to go ahead and break out. And if we say, sorry, we don't know who you are, we can say continue, in which case it's going to start the loop back over. Now, in this case, continue is optional. We don't have to have it. The code's just going to keep running indefinitely in there. But sometimes you will need continue in there if you're in the middle of a code and you say continue, which means it just continues on with the rest of the code. All right. In your homework assignment, you're going to have to use an example of using a break and a continue in there. Even if it's an inherited continue, don't need it, you still have to put it in because the homework assignment tells you to. So do that. So if we run this code here, we're going to use a combination of ifs and while. We can see what is your name. If I say Bob, it's going to say, sorry, I don't know who you are. Start that code all over again. Okay. If I say Jason, it's going to say my name is Jason too and ends the program. It would just continue on running with whatever in here. We say this program has ended. Then if we ran this and did the same thing, you'll notice if I type Jason, it prints that and then prints this next line that's outside of all that indentation. All right. I can do different things beside while true. I can say while num is greater than, let's see, while num is less than 5. And if I come up here and I specify a variable called number is equal to 0 or num is equal to 0, I can have this go through 5 times. So we can do something like this instead of a continue. We could say num plus equals 1, right? And then I can do a check before this whole statement that I do num plus equals 1 and say if num, actually it's not going to matter because while is going to take care of that. And we do plus equals 1. So if I run this program, right? If I do Jason, program still ends like we would expect it to. If I type in 5 names wrong, for example, I do Alice, Bob, Sam, Bill, Toby, notice the program ends up ending. And that's because at this point, num was equal to 5, in which case num is greater than, or I'm sorry, num equaled 6, right? We put 6 different names in, 1, 2, 3, 4, 5. Next one would have been 6. It would have killed that out of it. So at that point, it kills this while loop and automatically kicks you out. So this is nice. If you have a finite number of times you want the loop to go through, you can specify something like this as well. Otherwise, you can do a while true, keep them in there indefinitely until some condition matches. Then you can use a break loop or a break statement. All right, which does take us to the next one. Again, I showed you the annoying while loop, which just means you have to have something that matches. In this case, they're showing you this, which is real simple code. If you say name equals blank and you say while name does not equal your name, print, please type your name. It gathers their input. The only way to get out of this while loop is to type in what? Speed that up here so you can see that. You have to actually type the words, your name, right? So if I type Bill, Jason, whatever else in there, it doesn't matter. It's not going to accept it because it does not equal your name. So until you type in the words, your name, this condition doesn't match and therefore letting you out. It's the beauty of a while loop. It keeps you in there forever. Where will we use while loops? We will use that to sanitize our inputs later on. So for example, remember that we asked, what is your name? If I type in a number, there's no way for you to check to see if it's a number, right? We can use while loops later on to keep us in that loop until we get the information that we want. Once we get that information, we can kick it out. All right, we talked about while loops. We have break statements that will break you out of a while loop. We can also have continue statements that will keep you running inside that code and start that loop over. All right. Other ones that we have are for loops when used with a range. This is very beneficial if we have a finite number of times we want to go through a loop. So if we say for I in range, now range works with 3 different numbers. You can see it on the screen here. It goes with a start number, it needs a stop number, and you can use a step number. The way range works is I'm starting with 0 in this case. And if I say 0 to 10, that means I'm going to ask for every number between 0 and 10, not including 10. It's just up to 10, which means I'm going to get what numbers back? Zero through 9, right? So if I say for I in range of 0 through 9, now I can be anything. This is just you specifying the variable you want while in this loop. So the first time I is going to be equal to 0. The second time I is going to be equal to 1 all the way through. If we come down here and just say print I, we can see this program. So let's run. If I say my name's Jason, we'll see that it printed out those numbers. So the first time it went through this loop, I was equal to 0, then 1, 2, 3, 4, all the way till it hit 9. Note that it did not include 10. And it's important on this range that you get that part because it's going to be confusing with some other ones later that do include it. The range command does not include the last number. So if it's 0 to 10, it's only those numbers from 0 to 9. All right. You can put a step in there. So say I just want the even numbers. If I put a comma 2 in there and I run this, then it's only going to give me the numbers from 0 to 10 using the even numbers going up. Notice how it doesn't include 10 inside this list because of what we have there, right? If I wanted to include 10, what would I need to change this number to? 11, right? So if I put in 11, I run this, go to Jason, I'm now going to get 0 through 10. Anybody have any questions on the for loops? Yeah. No, they need to be whole number integers. Yep. Good question. So the question was, can you use floating numbers up here instead of integers? And no, you need to use integers. As a matter of fact, if you start typing this, it will ask specifically for integers. It doesn't in this particular case. It usually tells you that it needs to be an integer inside of there. So if I do 1.0 to 2.2, fairly certain that doesn't work. The last time we tried that, print I. Yep. Got to be integers. And it specifically tells you that, right? Float objects cannot be interpreted as an integer. Okay. Now you could convert those over, right? We could use the int statement to convert those over to integers. And if we do that, get a name, and you can see it ends up just coming out as 1. So it ends up basically rounding that from 1 to 2, and therefore we're only going from 1 to 2. Therefore, it's only going to print the word 1 out. All right. So now you guys know about while statements, you know about for loops, you know the break and continue statements. You can also use a for loop to an equivalent of a while loop, which is what we just showed you before, meaning that instead of for I in range of 0 to 6, therefore let me have 5 tries at something, right? It's going to go loop through 5 times. You could do the same thing in a while loop where we set a number of I equals 0 and say I is less than or equal to 5. Then we just make sure we do I plus equals 1. You can also, and we'll talk about this more, I kind of sped ahead in that part, but if you go back and look at our code, instead of num plus equals 1, you would use num equals num plus 1 is the same thing, right? Which is makes more sense based on what you guys have done so far. You can shorthand that to plus equals 1. What you can't do is equals plus 1. A lot of people mess that one up. It's not equals plus 1, it's plus equals 1. Or you can do minus equals 1 would also work as well. Or 10 or whatever you wanted the engine to be. All right. Let's see here. What else am I missing? So we talked about the range command. Again, you have a starting spot. You have the stopping. It goes up to but does not include. And then you have the stepping argument, which is going to ask how often you want that in there. So in that stepping argument, I can use that how much I want. So if I go back to range and I say from 0 to 100 and we print I can set a step of 1. Obviously, that's what it is by default. If we put in 2, it's going to do every other. You can do by 3s, 4s, 5s, whatever you want. So if I go by 10s, then it's going to give me all of the 10s out here. Oops, I forgot my colon. And you can see you can get all the 10 values out of there. So this can be helpful in your code if you needed to print everything out. Instead of making up a list of all these, you can use a range command to build that for you. We'll talk about lists and all that stuff here later down the road. All right, does anybody have any questions on any of these conditional statements that we talked about? I feel like I went through that fast, but I always go based on student feedback in the classroom. So if you guys are getting it, I'm not going to sit there and spend 20 minutes on it just because I have 20 minutes to spend on it, kind of thing. All right. If you have questions or you don't feel like I covered it well enough in this session, go back and watch the other videos from the other sessions because people ask questions all the time. You asked about the float part. I don't think I've ever been asked that. So somebody's going to use this as a reference for that, right? That's why I say ask questions because somebody hasn't asked it before. Somebody else is going to have that question at some point. Yeah.
For this, like under the while thing. So if you get a correct, like say you wanted to make like a game or some kind, you're trying to guess the person's name, if you get it right, essentially one spot, if you get it wrong, essentially their spot.
Yep.
So since both would break, how do I determine which one would be the correct one and like wrong? Say like you guess my name right, it breaks it out. How would I make sure? Like how would I tell it that's right? So we can have it print that different.
That comes into here, right? So for example, if we have this, we could say, let's just use a while true, but there's a couple ways to do it. While true, we're going to get a name in, right? Equals input. What is your name? And then you're wanting to check to see if your name is something. So let's say if that name is Jason. And if it's Jason, we're going to do something, right? We can say print, hello, Jason. Welcome. Something like that, right? Then if we are no longer wanting to check if that name is equal to Jason, we would break out of that code. Now, if you're wanting to check if it's another name, we would use an elif. So say that name is equal to Alice. And we would print, sorry, Alice, but you don't get access. And if we have an else, we can print something like, I don't know who you are. So in this case, the only way we're going to get out of this while loop is if we are Jason, right? If I'm Alice, at least we're going to recognize that it's Alice, but we're going to give her a different feedback than anybody else that's in the system. So if we come through here and run this code, if I say I am Alice, I'm going to get a specific back for Alice, but I'm going to start that loop back over again. If I say I'm Sam, I just immediately say I have no idea who you are. If it's Jason, I say welcome and I go ahead about my code. Again, this is really, really good to where you can have the rest of this code down below here. So if I print something like, let's do a hashtag. Does anybody remember what that line will do? Right. It's going to use string what? String replication, right? So we're going to use string replication to repeat that hashtag 20 times. I can do INF360 here, print this same thing over. Say something like welcome to. And so now if I run this code and I happen to be Jason, it's going to say, whoops, there you go. And now we can actually get into a menu to get into your game or something like that, right? Say you're trying to have them pick a item out of a tool bag and you print and say that there is a fork, a spoon, and a knife kind of thing, right? If they don't pick one of those three, then you just keep them in that loop. So you would have an if statement, if fork, if knife, if whatever, if you want an individualized print statement, or you could use one of those Boolean ors, right? So let's do something like that. Say print pick an object. And we could say fork, knife, and a spoon, right? In this, we're going to change this prompt just to a prompt. And we can say if, let's pick utensil here. All right, if utensil. So say we just want to make sure that they pick the proper utensil. All we have to do is come into utensil, and where we say it's equal to, we will say if it's equal to fork, right? Or if utensil is equal to knife, note the spelling here, or utensil, oops, sorry. Spoon. Then we will go ahead and tell the user print, thank you for choosing a plus, and we'll say utensil so that we can string concatenate, tell them back what they chose. Otherwise, we just say else print that is not a valid utensil. If it's a valid one, we want to make sure we come up here and break and run that out. So if we run this code, we can now check to see whether they typed in fork. Remember that fork is not going to take anything because it has to be a capital F. So if we take a dagger or something else, it's going to say that's not a valid utensil. Pick one of those items. In this case, if we say knife, then it just says, thank you for choosing a knife and moves on. Now, if we want a different statement for each one of those objects, then we don't want to use this or. We want to make sure that we use different elif statements. So we would want something like elif utensil equals knife. Elif utensil equals spoon. Then we can go through and actually set different statements if we wanted to. You chose the fork, great for blah, 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 right? If we want a different one for knife, then we can have a different print statement based on their knife. Anybody have any questions on that? So a lot of times what you can do here is you can have something like their name come in. And this will kind of be like a little bit in your homework assignment. So if we say something like print, what is your name? right? We get their name. And then we ask print, what is your age? We set their age. Okay. And we can say if their name is equal to Jason and their age is equal to a number, say 44, then print, hey, Jason, something simple. We could have an elif name is equal to Jason and age is greater than 44. Then we can have a statement here. And we could have other checks, whatever we want to check along the way, right? So even if we don't want to check this, say if we just want to say elif age is greater than 30, then we can go ahead and print you are middle-aged, even though that's not correct, but we're going to say it anyway. And we can go on down. Now notice that these are being checked in order. So even if my age is 44, technically I'm greater than 30, right? But it's going to check these in that order. So it's going to check this one first. If it matches, great. It'll execute this code. If not, it goes on down to the next one. So you always want to put those in a hierarchy that those end up matching. And that'll be important in your homework assignment that you work on this week. All right. This first one's going to make sure that I'm specifically 44. This other one's going to check to make sure that I'm greater than 44. So if I'm Jason, but I'm 33, then this is going to go down to this code and say I'm middle-aged. But if I'm Jason and I am 22, then it's going to not print anything at all, right? Because we don't have an else statement. If I am Sam and 22, I'm going to get nothing at all because we don't have an else statement. If we throw in an else, then we can just print whatever we want. Okay. That all kind of makes sense? Now, will this code execute? Anybody in the chat? We go back to the code. Will this code execute? There's an error in this code. What is that error? Has to deal with age. You got it, right? Because when we got our input, it's always a string, right? So we have to make sure we convert that over to an integer if we want to do a math comparison over here. So because we're checking that against an integer, then we need to make sure that we convert age over to an integer so that we can then convert it to 44. If I want to do just a straight comparison, I could just say age, and I could say this as a string. That would be fine. But if I want to do greater than, less than, equal to, any kind of math really on it, then I have to make sure I convert this over to an integer here. Good catch. Yeah.
When you're doing the for I in range.
Yes.
What data type is I? Because let's say that you're doing a program where you want to do if the base number is square, then the third power, the fourth power, the fifth power. As it gets larger, and you're just wanting to print I. Can you change the data type?
You wouldn't in a range, right? Because for range, you're only taking in integers in there, and therefore I is always going to be an integer. Okay. Now you can assign I to be number or Jason or whatever variable name you want. It doesn't matter. But in this case, you're always going to get an integer because that's really what comes out of range. Range essentially gives you a list of those integers is really what it returns back. We'll talk more about lists, but.
So you'd want to assign it to something else.
Right. Right. Anybody else got any questions? Great. All right. So last couple things that we're going to talk about here today. Again, I feel like I'm going really fast for today. So if you guys need me to slow down or have more questions, by all means, please do that. There's a couple of things that we need to import when we're using Python programs. So by default, there's lots of things built in. Your print statement that you're asking for, your print function, is built into Python. The range function is built into Python. But there's some things that we need to use, which are modules that we have to import in at the beginning of our programs. So it's very important when you use imports, it doesn't matter why you're using it, where you're using it in your code, you always put your imports at the top. So in this case, we're going to import a module called random. And what this will allow us to do is use the random module, which has a bunch of different functions. In this case, we're going to use the random integer number to get a random integer out of that. So if we call this random number, right? And that is equal to random.randint. And then we pass that two numbers. It wants a random integer between those range. So if I say a random integer between 0 and 10, similar to what we did with the range command, it's going to be a random int. The difference is on this random number part, it's actually including the last number too. So this can give you any random number between 0 and 10, including 0, including 10. All right. Then we can go ahead and print that random number. And it would go through. Now, I'm going to cheat this program and just throw this into a while true loop. And if I do this, then the first time we get a random number, it's going to print it. Then it's going to execute this code again and get a whole nother random number. So if I run this, it should be in a while loop that will randomly print a bunch of different numbers. Notice that sometimes it'll give you the same number. Sometimes it'll give you different numbers in between. Remember, Control-C can get you out of that. So notice here, we got 2 1s in a row, right? And then we got 2 0s in a row. It's just randomly picking a number. Now, if you're building a program that really needs a true randomness, don't use random int, right? There's better ways to calculate random numbers. But if you're just in the basics here and we're playing a guess the number game, which is what most of what your homework 2 is about, then you can use a random integer. That works fine. All right. You can set these variables to whatever are these numbers as high as you want. So a random number between 1 and 10, or 0 and 10, whatever you want it to be between. Anybody have any questions on this import for using random? All right. There's lots of things that we'll import over time. Other ones that we may use is going to be import OS. We will use this when we start dealing with files. It's best practice in Python to put each one of these on their own import line. You can use a comma up here and use OS if you want here, but it's best practice these days to put them on their own line. All right. One that we will definitely use is going to be import sys. This allows us to access the sys module. And in this case, what we would use sys for is sys.exit. So if we say sys.exit down here, or even better, if we come up here with what is your name, and if your name ends up being Jason and you're 44, we are going to do a sys.exit and end our program right away. This allows us to end our program immediately. So if we run this, and let's take out this while true loop so we don't get stuck in that. So if I am Jason and 44, then it will print, hey, Jason. Notice how the program just ends at that point. It never went down here and it never executed this welcome code that we had before. If I comment this out, notice that if I run this program, it's going to ask for this. I say Jason, I say 44. What is your name? It just kept me in that loop, right? Because I have no break out of here. So this sys.exit just ends the program. Now, there's a couple other ones you could use. There's exit, there's end, there's some other ones. But by using sys.exit, it doesn't prompt me to close the program. It just ends the program. It's a much cleaner way of ending your Python programs. A lot of times you'll use this if you want the program to end early. We will use it when we do checks and balances early on in programs. If things aren't imported right, or maybe we're missing some stuff, we'll go ahead and exit the program. Anybody got any questions on imports? Again, always, always, always do your imports at the top of your program. So the start of your program should have your initial comments, right? Get those in there, then followed right below that should be your imports that you're going to do. If you're not using different things, don't import it because it takes up more memory within your program. So it's only used for different things. For example, say I just want that random integer function. If I say from random, import random, import rand int, that will just import the rand int function into my program, in which case I don't have to say random dot rand int. I can just say rand int. So rand int. Plug in a 0, 10, and it will randomly get an integer. And I can say this is my number equal to that. All right. That allows you to import one piece of a much larger module or class. We will use this later on in your guys' projects. You can do that. If I want to import every option that random has to offer, and I want it to be native, I can use a star. This will import everything in. So now instead of just rand int, I can use random choice. I can use all sorts of things that are available in the rand function or in the random module. It's best practice to use straight random, import that in, and use the rand int function like we had before here. So if I go back to just import random and I use random dot rand int and int, then I pass in my 0 to 10. Okay. You can do it the other way. What this does though is makes you remember that this particular function came from the random module. If I just imported in my project, I may have forgot what module that came out of. So anybody have any questions on importing? All right. Like I said, there's other modules you would use. Math is another one. There's some math functions specifically if you're trying to do quotients and log algorithms, things like that. You may need to import math in order to use that in. We talked about sysexit. This is going to allow you to end your program early. All right. And so that takes us into this short little guess the number game. Again, this is going to get kind of into your homework. You can use a short program here that teaches you how to play rock, paper, scissors, and you guys can go through that source code. I encourage you guys to use both of those short number games or those practice exercises, as it's going to help you understand how to use elif statements, things like that. Simple game, but at the same time, the code, when you look at the logic, you have to think about how that game works, right? Simple rock, paper, scissors. We got to make sure you chose rock, paper, scissors. If they didn't choose that, we spit it out. If they chose rock, then we need to make sure that rock beats rock or rock equals rock is tied. Those kind of truth tables you have to build out. Anybody have any questions on any of this stuff? Very simple flow control. All right. So on Thursday, we will go through the homework assignment. And so we'll do that in class for the most part. And that way you guys shouldn't have any homework for the weekend because we're going to go through and give you an example. You just need to make it your own inside of there. All right. Anybody have any questions on how class works, that kind of stuff into week 2? Some of these sections won't go this fast. When we get into the deeper content, it takes 2 sessions to get through it all. But a lot of times I try to make sure Tuesday is the session we go through the material. Thursday's a session that we go through your homework assignment if there is one. If there isn't homework assignments that week, you actually have a free day to go work and kind of expand on, especially once we get towards your midterm projects and final projects. I give you tons of class time. So if you don't have time, you're in sports, activities, whatever else, there's lots of class time to work on your stuff. All right, I'll end this video and that'll be it for today.